morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and today we are talking about derivatives of inverse trigonometric functions while listening to the classic band The Cure. And just like Kevin, let's get to it, shall we? Okay, so let's make sure that we know what inverse trigonometric functions are. Sine negative 1x is not 1 over sine x or cosecant x. It is not that. Sine negative 1x is the inverse function of y equals sine x. In other words, usually if I do something with sine, I'm saying, what's the sine of pi over 3? Or what's the cosine of pi over 3? Well, the inverse sine, the arc cosine, the inverse sine, the arc sine, you are given the angle measure, and then you're finding the angle. For example, the arc sine of the arc sine of the square root of 3 over 2 is pi over 3, because the sine of pi over 3 is square root of 3 over 2. Now, the reciprocal function of sine is cosecant. That's 1 over sine x. So let's make sure we understand that. But what we're talking about today are the derivatives of our inverse trigonometric functions. So if I have y equals arc sine x, then here's what we're doing. That's what I was saying before. X equals sine y. We are given the angle measure and looking for the angle. Dx dy is cosine y, which is equal to the square root of 1 minus sine squared y. That's cosine y is, okay? And dx dy then equals square root of 1 minus x squared. And then using the chain rule, we get dy dx equals 1 over square root of 1 minus x squared. So this is just a proof of the derivative of arc sine x being 1 over 1 minus x squared on the domain of arc sine. Similarly, we can find the derivatives of arc cosine and arc tan. Now, we got some good news for you. I mean, they're all similar. They're all something over the square root of 1 minus x squared, except for, well, the sine and cosine are. And tangent is 1 over 1 plus x squared. So they're not that hard to remember. And remember, you got your good friend, the IBHL formula booklet. And looky here, kids. There they all are for your viewing pleasure. And a reminder, we've got the derivatives of all of our basic functions. But let's get to some examples. Very straightforward. I want to move this over a bit. Find the dy dx for y equals arc cosine of the sine of x. So we get a little chain rule action going. So dy dx is going to equal negative 1 over the square root of 1 minus sine squared x. And where do I get that? Well, the derivative of arc cosine right here. Oops. And my x is the sine x, and this is the chain rule, the derivative of the outside function, arc cosine, times the derivative of the inside function, which is cosine. And we really need to simplify this. It's too easy not to. So this would become negative cosine x multiplying here, and of course the square root of 1 minus sine squared is the square root of cosine squared by the Pythagorean identity. And the square root of cosine squared is cosine x. Woohoo! This is equal to 1. So very, very straightforward. Only one more example. How you like them apples? So dy dx for y equals e to the negative x arctan x. Little chain rule action going here. So we're going to say dy dx is equal to the derivative of the first term, which is e to the negative x multiplied by the derivative of negative x, which is negative 1, times the first term. So I'm going to write arctan as tan negative 1. It's just easier. Plus the first term, e to the negative x, multiplied by the derivative of arctan, which is 1 over 1 plus x squared. So we clean this up a bit and multiply through by there. So negative e to the negative x, tan negative 1x, plus e to the negative x over 1 plus x squared. That is good enough. I suppose we could do this if we wanted. Tan negative 1x over e to the x, and of course this negative is still there, plus 1 over e to the x times 1 plus x squared. You can manipulate it however you want. I would say we should at least get to there. And so I believe that's all there's going to be. Hope you enjoyed it. As always, I know I enjoyed it. And with that, we are going to go back to the great cure, and I am going to say that I am out.
Show me how you do that trick. The one that makes me scream, she said.